Hello dear students, I Ganesh welcome all of you to this session of plus 2 second year mathematics, and today our topic of discussion is on the chapter of determinant. It is a part of our chapter matrices and determinants. Okay, so let us begin with a quick recap of this chapter determinant, and we are going to discuss it today with some of its important properties. Okay, my dear students, so let us start it. You know that there are various type of matrices, and you know already the definition of matrices. In our previous classes, you know those things. So what is a matrix? You know matrix is a arrangement of numbers in a rectangular manner. Okay, for example, if I say your matrix, this is a matrix of order what? Of order 1 by 3. Yes or no? It is the matrix of order 1 by 3. Now we already know the definition of square matrix. What is a square matrix? If in a matrix the total number of rows is equal with total number of columns, then that matrix is called as square matrix. For example, I represent a matrix, this one. This is called as a square matrix. Okay, you know matrices are represented in between your square brackets. Okay, so this is a matrix of order what? It is of order 2 by 2. Now why I am going to give a concentration on this square matrix? Because determinant is derived from it. So now let us come to the definition of determinant. And what is the meaning of determinant? That every square matrix, if it is a square matrix, it has a unique number attached with it. Okay, a unique number is attached with every square matrix. So that number, that unique number which is attached with a square matrix is known as determinant. So I can go for the definition again, that every square matrix. So introductory concept, the concept of determinant. On the concept I can say every square matrix is associated. Every square matrix is associated with a unique value. With a unique value is known as determinant of the matrix. Is known as determinant of the matrix. Okay, and it is symbolized that, and if A is the square matrix, then its determinant value or determinant is denoted as or written in this format. Okay, dear students, so this is the concept of determinant. And what is the meaning of determinant? That if there is a square matrix, I am using this one. Okay, now I have a square matrix. So this matrix is attached with a unique value. So to find out the unique value and the unique value with which it is attached, or the value of that matrix, is called as determinant. Okay, so this is the concept of determinant. Clear, students? Now we will go for the some other things of the matrix. Okay, so let us see what we are going to deal with. So I can say determinant. So next is determinant of matrix A, of the square matrix A is represented as I already told you. Okay, it is not it is not an arrangement, is not just an arrangement of numbers, rather it is to find the unique value attached with it. Okay, dear students, so this is the some of the concepts of a determinant. Okay, and it is definite. The unique value is definite, and we have to find out that unique value for a matrix. Okay, so with this I can give another note. The determinant of A, which is we should read as determinant of A, not as mod A. Many students are thinking that or reading it as mod A. Okay, so it is not modulus, it is the determinant value. You know, though it is looking like it is represented in between two vertical straight lines, but don't think that it is the symbol of modulus. It is the symbol of the determinant of the matrix A. Okay, my dear students, so these are the some basic concepts or some introductory concepts of the determinant. Next we will go for the some other concepts, and we will check out how we can find the determinant value of a square matrix. Okay, so let us begin it with the finding of value of the determinant of a square matrix. Okay, so I am cleaning it now. So before going to find the determinant value, I am going to give you another information on determinant, that a determinant having n rows. So if a determinant having n number of rows and n number of columns, because it should be a square matrix, then only you can find the determinant. Okay, is known as, so if a matrix having n number of rows, then it has for the square matrix it has n number of columns also. Then only if it is not a square matrix, the determinant value cannot be find out. Okay, so if a determinant is having n rows and n columns, is known as a determinant, is known as a determinant of order n. So it is a determinant of order n. For example, if somebody write 3, okay, what is the order of the determinant? You can see it is attached with a unique value. Okay, it has only one row and one column. If you go horizontally, it has one row. If you come vertically, it has one column. Is of order 1. Okay, now this one, this determinant is of order, it is of order 2. Okay, dear students, So in this way we are going to define the order of a determinant. This one 3, 5, 8, 4, 6, 9, 8 minus 1, 3. What is the order of this determinant? Is of order 3. So in this way the determinants of various orders can be defined. Okay, dear students? So this is the way to define the order of a determinant. Okay? Now let us move to find the value of a determinant. How we can find the value of a determinant? Let us check it. So I am cleaning it now. So next we will go for determinant of a square matrix. Next is determinant of a square matrix of order 1. Okay. So we are going to find the determinant of a square matrix of order 1. How to find the determinant value of a square matrix whose order is 1? So it says if A equal to Aij, only one element is there, okay, then why Aij? It is simply A11 because it has only one row and one column, okay. Then its determinant is written as like this, okay. And how it is, what it means? It means like this one. And what is the value of this unique number? This is equal to only A11, okay. So in this is the, if this is the matrix, then the determinant is this one. Okay, dear students? Now we will go for determinant of a square matrix of order 2 that we are going to find. How we can find the determinant of a matrix of order 2? Okay. Suppose let A equal to, I am writing a square matrix of order 2. It is A11, A12, A21, A22 with specific positions. Okay. Is the square matrix is of order 2? It is a matrix of order 2. Then its determinant value of A, which is equal to represented like this, and it represented like this: A11, A12, A21, A22. Okay. And how to evaluate it? Now look carefully how to evaluate it. It is very important for you. We have to multiply the diagonal elements. Okay. So that is, it is equal to A11 multiplied by A22 minus, we have to again multiply the other diagonal elements, that is A21 multiplied with A12. So this value what we obtained at here is called as the determinant value of this matrix. Okay. So in this way, let us take one example to clarify the concept, to find the value of the determinant of such type of matrices whose order is 2. Okay. So I am cleaning the above portion. So you see, let us take one example for your clarity. Find determinant of A. It is given, find determinant of A if A equals to 1739. It is given. So clearly you can see this matrix is a matrix of order 2. Okay. So it is a square matrix. Then we can find its determinant value. Otherwise not. If it is not a square matrix, then we can't find its determinant value. So it is a square matrix and it is of order 2. So its determinant value can be found. Therefore the determinant value of this matrix, the determinant is denoted like this, and it means this one. And it is not just an arrangement of numbers. We have to find the value attached with this representation. And how to find the value? As I told you, I have to multiply the diagonal elements, that is 1 multiplied by 9 minus the multiplication of the other diagonal, that is 3 multiplied with 7. So it is 9 minus 21, that is minus 12. Okay. So this is either a positive value or a negative value, whatever may be, but we can find the unique value which is called as the determinant value for this matrix. Okay. For this matrix, this is the determinant value. In this way, we are able to get the determinant of such type of matrices whose order is 2. So let us clarify with some more examples. Okay. So take another matrix and let us try to find. For you I am giving those examples. Look carefully. My dear students, look carefully to the board. Okay. So another example is there. Find determinant of B. Okay. Or like this. If B equals to, it is given. If B equals to sec theta tan theta sec theta. Okay. So we have to find, suppose this is the matrix format is given and we have to find the value. Okay. First of all, determinant of B is what? It is equal to, we have to represent like this. If nothing is given, simply this type of representation is given, means we have to find out the value. Okay. Or if it is given in the matrix form, then while finding the determinant, we have to represent it in determinant manner, then only we can find the value. Okay. So what is the value? How to get the value? Just multiply the leading diagonal elements. Sec theta multiplied with sec theta. Okay. What we obtain? Sec square theta minus, we have to multiply the other diagonal elements. Tan theta multiplied with tan theta. What is the value? Tan square theta. So sec square theta minus tan square theta. What is the representation? Or what is the value? It is equal to 1. So this is the determinant of this determinant value for this square matrix. Okay, dear students, in this way we are able to get the determinant value of the matrices of order 2 or determinant of order 2. Next, move to find the determinant of order 3. Okay. Next, our topic of discussion is to get the determinant of order 3, to get the value of the determinant of order 3. So next topic of this discussion is determinant of a square matrix of order 3. Means if it is a square matrix and it is saying order 3, so how many rows are there, how many columns are there? Please think over it. How many rows are there, how many columns are there? Very good. It has 3 number of rows and it has 3 number of columns, and we have to evaluate the value attached with the determinant. Okay. How to get the value? You see, for it, let A is a, suppose A is a square matrix and let A is equal to this one. Okay. So suppose this is A and it is a square matrix and it is order is of order 3. Then its determinant value, how we are able to get the determinant value of this matrix. Okay. Then determinant of A means this one. I am representing it now in the determinant form. And now if it is written in the determinant form, how to get its value? Dear students, look carefully how we are going to find the determinant value of this type of square matrix whose order is 3. It is, you can expand it from any row or any column, but I am starting from the first row. The evaluation, the expansion, the finding of value is started from first row. You can start from any row or any column also. So if I start from first row, this is called as first row expansion. So I am taking it is equal to A11. With this, what you have to do, you have to leave the other things, other elements present on that determinant. Okay, of that particular element. If it is so leaving it, what are the elements you found? You find the and write it in determinant manner. It is A22, A23, A32, A33. Now next come to the second element, that is minus, and for your information, again we will what we have to do, we have to eliminate the row and the column where it is present. So we have to eliminate this row and eliminate now this column. Now what is remaining? So it is A12 multiplied with A21, A23, A31, A33. Again plus. Okay. Then what we have to do? Again we have to remove the row and the column where the element is present. So it is again A13 multiplied with what? A21, A22, A31, A32. Okay? So in this way, and it is equal to what? It is equal to, how we can evaluate it? It is equal to A11 multiplied with, now how it is evaluated? Okay? A22 multiplied with A33 minus A32 multiplied with A23 minus A12, how we can evaluate it? A21 multiplied with A33 minus A31 multiplied with A23 plus A13, and how you can evaluate it? It is A21 multiplied with A32 minus A31 multiplied with A22. Okay? So in this way, we can evaluate this result is called as determinant of this square matrix of order 3. Or in this way, the third order determinants can be evaluated. Okay? We have to, again I am going to tell you what we are doing. We are taking the element of the first row, then we left the row and the column where the element is present. If I remove that one, you see, if I am removing the row and the column, you see it is remaining A22, A23, A32 and A33. Represent it in determinant manner. Then take a negative sign, minus. It takes the, I am going to tell you that while finding a determinant, we have to alter the sign, or the sign alters. That is, it is evaluated in a zigzag manner or in alteration method manner. That is plus, then minus, then again plus, then again minus. Okay. So in this way, the determinants are going to be evaluated. So I am putting the second, for the next one I am writing A12. With this, what I have to do? I have to eliminate the row and the column where it is present. So eliminating the row and the column, you see it is A21, A23, A31 and A33. Then for the next one, as it is plus, then again minus, then again plus. Okay? So with A13, what we obtain? A21, A22, A31, A32. Okay? In this way, we have to evaluate the determinants of order 3. Let us, for your clarity, take an example, because example is the better way for explaining a thing. Okay, so for your clarity, let us take one example and see how we can able to find the determinant of order 3. Okay, so I am cleaning it and I will take an example of order 3 and I will find out its value. You see how we are able to get the value of a determinant whose order is 3. Dear students, please make a note of those things. Those are very valuable information for you. Okay, so let us take one example. The example is, find, suppose I take a third order determinant whose first row is 2 minus 1 2, okay, and the second row is suppose 0 2 minus 1, and the third row is 3 minus 5 4. Okay, it is given. So given, evaluate or find this value. If it is represented in a determinant form, you directly evaluate it. If it is given in a square matrix form and given find the determinant value, first of all you have to convert it in determinant form, then you have to find the value. Okay, now it is given in the determinant form, so no hesitation is there. I am going to find it directly. So it is evaluated in what type of manner? We will start from the first row of the first and from the first element, that is 2. 2 is going to be multiplied with what? Now leave the row and column where 2 is present. This 2 is present. Okay, leave the row and column. So leaving the first row and the first column, what do you see? We will get 2 minus 1 minus 4. Write it in determinant form. Then for the next element, that is minus 1 is there. So put a minus symbol and write the next element. And similarly, leave the row and for the next element, what we have to do? We have to remove the row and the column. So we have to remove the first row and the second column. And the remaining elements are 0, minus 1, 3, 4. So write 0, minus 1, 3, 4. And then for the third element of the first row, that is A1, 3. So it is again 2 with plus sign. Now we have to take plus sign. What is there? 0, 2, 3, minus 5. Okay. Now how to evaluate it? We know the evaluation of a second order determinant. So it is 2 times of 2 into 4, 8. It is evaluated like this, minus 5 into minus 1, again 5. It is minus multiplied with minus, it is plus 1. And how it is evaluated? The leading diagonal elements initially multiplied. 0 into 4, so it is 0. Minus 3 into minus 1, minus 3. Then again 2 is there. Again how it is evaluated? 0 into minus 5, it is 0. Minus 3 into 2, 6. Okay. So what we obtained? 2 multiplied with 3, 1 multiplied with 3, 2 multiplied with minus 6. So it is 6 plus 3 minus 12. So 9 minus 12, the value is minus 3. Okay, dear students, in this value, what we obtained at here is called as determinant value. This is the determinant value, or this is the determinant of the third order. This is the value of the determinant. In this way we can evaluate a determinant of third order. Okay, understood? You follow the concepts? Very good. Or okay, we will give some more examples. Okay, so now I am going to give you another example of third order and we will check out how we can find the value of the determinant. Those are able, please try it and try to calculate the determinant. So for your convenience, I am giving another example of a determinant whose order is 3 or third order determinant. So you see, Now I am giving another example. So it is given, find the determinant if A equals to, it is given okay. So you see, it is a square matrix of order 3 and we have to find the determinant value attached with this matrix. Okay. So here solution, I am going to write the solution. You see here, determinant of A means we have to write the matrix initially in the determinant format. So it is 3 minus 5 4, then 1 7 6, again 2 0 8, and now I have to find the evaluate it. How? As I told you, I am starting from the first row. Conveniently, you can take any row, you can take any column. That is your choice, dear students. But generalization is there, and for a convenience, we are taking the evaluating from the first row. Okay. So from the first row, we can evaluate it, and we can find the determinant value of this third order. Okay. So I am going to find the third order. So how to evaluate it? Let us find it. So it is 3 multiplied by, what I have to do? 7 6 0 8. Then from the next, for the next element, it is minus, I will put, it is minus 5. It is written as 1 6 2 8 plus 4 multiplied by 1 7 2 0. Okay. So it is equal to what? It is 3 multiplied by 7 into 8, 56 minus 0. You see, it is initially evaluated from the leading diagonal. 7 multiplied by 8, 56 minus 0 multiplied by 6, 0. Minus minus again plus 5 multiplied by 1 multiplied by 8 minus 2 multiplied with 6, what we get? 12. Okay. Then plus 4 multiplied with 1 multiplied with 0 minus 14. Okay. So it is 3 into 56 plus 5 into minus 4 and 4 into minus 14. So it is 168 minus 20 and it is minus 56. So 168 minus 76. Okay. So that we have to evaluate. So it is equal to 92. So this is the value of the determinant. Now you are clear, my dear students? Okay, very fine. So we obtain the determinant of a third order and we know the procedure of a third order determinant. Okay? Clear? Now we will go for some of the important notes of the determinant. Okay? So I am going to write some of the important notes of the determinant for your information. Initially, first again look how we are getting the information and we will go for some of the important notes. Okay. So with this I am going to write some of the important notes. Okay. Write down and look them or verify them. The first one says important notes. The first one says the value of the determinant is same. The value of determinant is same when expanded by any row or by any column. Is same when expanded by any row or by any column. Okay, so this is one of the important note for you, that if you evaluate it either in row wise manner or you start it from any row or from any column, whatever your choice is, the value of the determinant is always remains the same. Next, the value of determinant is 0. The value of a determinant is 0 when all elements of a row or column. So if all elements of a row or column is equal to 0. Okay, what it means for you, I am giving some example for it. Okay, this is one of the important thing. You see, suppose one determinant is there and you have to find out. Suppose 3040. You see, it is a second order determinant, and its second column, its all entries, you can see that all entries are equal to 0. So if all elements of a single row or a single column is 0, the value of determinant is 0. You can evaluate it. It is 3 into 0 minus 4 into 0, so it is equal to 0. Okay, so it says that the value of determinant is 0 when all elements of a row or column is equal to 0. Okay, dear students, so this is one of the valuable information for you. Next, determinant of an identity matrix that is, it is equal to 1. So whatever maybe an identity matrix is there, its value, the determinant value of an identity matrix is always equal to 1. Okay. For example, you can see, if I take an identity matrix of third order and it is equal to this one, so you can see what is the value of this determinant. You see, its value is equal to, the determinant value is equal to 1. Okay. So these are some of the valuable informations on determinant and on its evaluation. Okay, very important, very vital for you. Look, take a look on those things and see, these are very important informations for your exam point of view, for your calculation. It makes your calculation easier. Okay. Next, from here we will move to some other concept, and it is a newer one, and I am going to tell you. Next we will, so now we are able to find the determinant of any order. Okay, any order means it is a square matrix of order 1, order 2, order 3. Generally we are taking up to order 3 in our level. Okay, now we will move to some other concepts of determinant, that is minor and cofactor. Now we are going to discuss on those things, and minor and cofactor. So dear students, now we are moving to the concept of minor and cofactor of a determinant. For your information, I am taking the minor and cofactor now, and I will going to tell you that what is the minor and cofactor of a determinant. Okay. So let us take a square matrix. Okay. So I am going, first of all, initially I will take a, I am going to tell you the concept of minor. Okay, the concept of minor. And I'm going to show you the definition, then we will later move to some examples. The minor of any element Aij in determinant of A. So if there is a determinant and there is one element in that determinant and that element is Aij, then its minor is denoted as Mij and evaluated by deleting by the determinant, deleting the row and the column. Where Aij is present. Okay? So this is the information on the minor and what it means. Let us, I am going to show it. Let A equals to, suppose I am taking the determinant of A, the determinant of A equal to, suppose this one, A11, A12, it is, let us take a third order, okay? And it is A21, A22, A23, A31, A32, A33. So it is a third order determinant, is of order 3, is of order 3. Suppose we take one element, suppose we take A11, okay? And where I am interested to find its minor. And what now we are going to, I am going to show you the concept of minor. Then, minor of A11, okay, it is denoted as what? M11. This is the representation. Minor of A11 is equal to M11. And what it equal to? How we can find the minor? By deleting the row and the column where it is present. So it is the determinant value obtained. That is A22 multiplied with A33 minus A32 multiplied with A23. Okay? So this is the minor of this element. Clear, dear students? Somebody asked me, sir, please find the minor of A23. The minor of A23 of this element present in second row and third column is this one. How we can find the minor? Okay? Who can tell me? Yes, dear students, please think over it and tell me. Yes, the minor of A23 is denoted as M23. And how we can find it? By deleting the row and the column where it is present. So this is the, now this determinant, that is A11, A12, A31, A32. And this determinant value A11 multiplied with A32 minus A31 multiplied with A12 is the minor. Okay? In this way, we can obtain the minor of the elements. Okay? Later we will go for the some particular examples and find out the concept of minor. Okay? Now we will go for the, and similarly we can find the minor of each and every element also. Now we will go for the cofactor. Okay, so this is the information on minor. Now let us move to the concept of cofactor. Okay. So I am cleaning it and we will go for the cofactor. Okay. So you see, now we are moving to the concept of cofactor now. So this is for your information. Now we are moving to the concept of cofactor. So I am giving the definition of cofactor now. Let determinant of A be n of order. Let us take up B of order 3. Order 3. Any order we can take. For convenience I am taking. Okay. Then, and let determinant of A equal to, suppose this one. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay? Then cofactor, now we are going to the cofactor, okay, of any element. Suppose on generalization I am writing Aij is denoted as Cij. It is the representation for cofactor. Cofactor of any element Aij is denoted as Cij. And Cij equals to minus 1 to the power I plus j multiplied with Mij. Okay? Where Mij is the minor, I and j represents the row and the column of Aij. Okay, so Aij is present in which row? That is denoted as I. Aij is presented in which column? That is denoted as j. That is the position. It represents the position. For example, here cofactor of A23 equal to C23. Cofactor of A23, what I am telling, that is equal to C23, and it is equal to minus 1 to the power 2 plus 3 multiplied with M23. Okay, minus 1 to the power 2 plus 3 into M23, that is minus of M23. That is minus of, and how M23 is evaluated, dear students? How M23 is evaluated? By leaving the row and the column. So it is equal to A11, A12, A31, A32. Okay, so it is minus of A11 multiplied with A32 minus A31 multiplied with A12. In this way, we can obtain the cofactor of each and every element of a square matrix. Okay, and from it I am giving a shortcut for you, that as you see, I am going to give you some of the important things. You can make a note of it also. And what the note says? The note says, as we know, Cij, the cofactor, is equal to minus 1 to the power I plus j into Mij. Therefore, Cij equals to Mij if I plus j is even, and it is minus of Mij if I plus j is odd. Okay, so for it's making a easier of the calculation, we are using it. Okay, so this is one of the concepts of the cofactor. Clear, my dear students? Now I am going to give you some of the other informations on the cofactor, And before it, let us try to find the cofactor of the find out the cofactor and the minor of a given determinant. Okay, let us take one example. If a equals to, it is given as if a equals to, the determinant of a equals to, okay, I am going to show you. If a equals to 2, 3, 5, 3, 7, 9, 8, 1, 6, find C12 and C23, okay. Also find M31. So now we have to find out C12. And dear students, C12 is what? It is the cofactor of the element present in first row and in second column, that is the element of 3. So it is, you see, it is present in first row and in second column. So we know C12 is what? It is minus 1 to the power 1 plus 2 M12. So it is minus of M12, and how it is evaluated? Minus of M12. Means it is leaving the row and the column. So it is 3, 9 and 8, 6. So it is minus of 18 minus 72. Okay, and giving some correction. So it is minus 54. So it is equal to 54. Okay. Now can we find C23? It is minus 1 to the power 2 plus 3 M23. And it is minus of M23 again. So minus of M23, second row, third column. Second row, third column means this one. Now we have to find its minor. How to find the minor? By leaving the row and the column from the determinant. Okay. So it is equal to 2, 3, 8, 1. So it is minus of 2 minus 24. So minus 22. So it is plus 22. Okay. And M31, for your information, if it is, we are going to find M31. Here M31 equal to the element present, the minor of the element present in third row and first column. So it is equal to, third row first column means 8. We have to find the minor of this quantity. How we will obtain? By leaving the row and the column where it is present. Okay. So it is 3, 5 and 7, 9 is there. So it is equal to 27 minus 35. So its value is minus 8. So that is the minor of M31. In this way, dear students, we can able to find out the minor of each and every element. Okay? And this is the technique of evaluating the minor and the cofactor of the elements present in the row and the column. And with this I am going to give you some of the important notes that write down some of the important notes for your exam point of view. Okay. It says, so it says, the first note says, if A is any square matrix if A is any square matrix, the sum of the product of elements of a row or column with its corresponding cofactors is equal to determinant of A, or like this one. Okay. The second note says, if A is any square matrix and the sum of the elements, the sum of the product of elements, okay, of a row or column multiplied with cofactors with cofactors of any other row or column, then determinant of A is equal to 0. Okay, that is, I am again explaining it. That is, if A equals to A11, A12, A13, A21, A22, A23, A31, A32, A33, then A11 multiplied with C11 plus A12 multiplied with C12, A13 multiplied with C13. So you see, the elements are multiplied with its corresponding cofactors. So it is equal to determinant of A. And A11 multiplied with C21, A12 multiplied with C22, A13 multiplied with C23, it is equal to 0. Okay. So dear students, these are the valuable informations for your exam point of view. So dear students, today we learned about the concepts of determinant. We learned about its order, and we saw how to evaluate the various order determinants, and we read about the concepts of minor and cofactor. Okay dear students, so what I hope you learned about these concepts, and we will meet with some more concepts in our next class. Okay, thank you. So thank you to all. With this, goodbye.